is a really important part of how we deliver applications. Evidently, it's so hard, not just for ChatGPT, who's like trained on whatever billion amount of projects, but also this is the Apache HTTP server project, one of the most popular, highly regarded, performant web servers on the planet, basically, right? Like this has been existing for like decades. Brilliant people are working on it, yet it still was possible to have a path traversal attack on this web server, back in like 2021 when a vulnerability was discovered. Not only that, but actually, if you look at my annotations, this is actually a vulnerability that happened because the previous vulnerability was not fixed correctly. So the prior fix was kind of like lacking, and then still a path traversal attack was able to happen. If you wanted to go ahead and to just go off and do this kind of attack, it's pretty easy. You just go, fire off curl, give the URL for it, use some URL characters, and the moment you do that, you have basically access to files on this web server if it is vulnerable, as the CVE says. Now, to find all of this, exploits and payloads and attack vectors, you don't have to go to the dark web. Simply have to go to Twitter, maybe with a dark mode on, and then people just share a lot of this information very openly, very happily to share with you all of their findings and how you can exploit and do a bunch of things like remote reverse shells. That's pretty incredible. So what is this path traversal that I'm talking about here for like a few minutes? So the dictionary for it is like, if you have not got basic security controls in place when handling files or file paths, you are essentially exposing sensitive file operations like Node APIs for the file path to attackers to be able to circumvent and do whatever they want there. And so if we look at specific controls of what this actually means, is we can locate here the key areas for us to understand what is the risk. So first off, this security controls that we don't implement are our insecure coding practices. Then if you couple that with user input originating obviously from users and then malicious attackers using that, and you do something with that user input, right? Like you save the file to disk, you scan it, you convert it, you do something with it. So you use file system APIs. Those are sensitive APIs that potentially could harm or do something bad to the system. And the output of that is path traversal. So again, if you wanted to maybe, if I'm running like a Node application or basically every other application, and I have usually save my credentials like database or API keys into config.json, someone could literally just try and access it. And if they did, they might be able to get my credentials. So like that's not something that you want happening. This is path traversal in a nutshell. Now, the repercussions of this are pretty severe, right? Because the moment, like if you think about it, it sounds like the attack is very simple. You just fire off a GET request or whatever with curl, and you just get a file. But those files may have actually very, very sensitive information. This could be, again, configuration files. It could be my package.json, which has all of my dependencies. Maybe one of them is vulnerable. Someone could use that against me. It has access to node modules, and then I can access, traverse files of source code of like not released, right? Like not open source packages because I use maybe internal private packages, my SSH key and other things. And people can actually use that and chain other attacks based on this from a path traversal to remote code execution and other things that are really bad. So we use those path APIs, on a very regular daily, if you're like doing, backend, server side kind of like programming things. And if you're not using them directly, there are probably dependencies that you use that probably use them, for you. Path join, path resolve, path normalize. But think of this for a second. Like these are just three very simple, APIs out of the whole stack of the core nodes path module. And see if you can actually understand the nuances and differences between each of them, because they exist, but are not very clearly communicated or understood. And so this is where things get interesting. So to understand more about path traversal, what I wanted us to do is essentially take a look at how NPM packages are vulnerable to this, how the node runtime could be vulnerable to this, and other sort of like vulnerabilities like that. So let's dive into one of those NPM packages. This is a package called ST. Very eloquently named because it helps with serving static files. It's got a ton of downloads, as you can see, over 1 million over a month. Pretty substantial. You'd probably use it for like an Express web application. If you wanted to use it, it would look something like this. You basically just use it as a middleware, and you say, all of my public assets is in this directory, and if someone adds /public to the URL, then they get, and you just serve files, right? Like static files on disk. If you use Astro, that probably uses behind the scene, the server-side rendering thing uses something like this, right? Because you have to provide static assets. Your JavaScript, your CSS, everything flows from this. So just by using ST and it being vulnerable, potentially here exists a path traversal vulnerability. To understand why, let's look at the code from ST and understand how that happens. Now, if you were, in this talk and you went home and try to install ST and even like the vulnerable version, simulated the whole thing and you did curl path as is, public / package JSON because you try to go to the package JSON of the node folder here, that wouldn't work. Why? Let's dive into the code of ST. So here is the code of ST. It's pretty trimmed, and I've kind of we'll take you through it like a debugger journey. And here it goes. First off, it gets the U variable. U has your URL, so it can be /public / whatever the input was, which is what we got there. And that is passed on to the URL parse, which is part of the core node module. And it gets specifically the path name, which is what you see on the screen. It does a bunch of regular expression, filters out some stuff. Okay, so far so good. And then passes this off to this API called path normalize. Path normalize is kind of like eval for JavaScript. So it's eval for URLs. What it does, or paths, what it does, it literally tries to evaluate the string to what it actually is. So if there's like a // it will evaluate what // means, which means go back to the top directory and then return that URL. So the result of path .normalize would be the following, because that's what it was evaluated to. So that passes on, and then you get return false, and get a 404 error. The file doesn't exist because there's like a check there with that if statement that says, hey, if the requested file is under a specific directory like /public, then reserve it. But in our case, we've normalized it, we've evaluated, and it's not. It's package.json. So seems like all hope is gone. Not so much. There's this other thing on the web that's called URL encoding. What it is essentially a way to encode reserved files on disk. Reserved file like on the URL characters. Things like like a dash or things like that. And so if you wanna say there's like a dot but provide it in an encoded way, you would simply encode it and get 2% e, and that's the representation of that string. So if I went ahead and done that, and now I would do %to e, let's see what happened. This is all real world path traversal attack on real world vulnerable dependencies of ST. And so I would give it to this function get path, which would then give it to the URL, path name. We continue with the debugging experience. We give it to normalize. Is there something to normalize here? No, because dot doesn't exist. There's no relative or absolute paths. %to e is simply a string of text. Doesn't really mean anything for the context of path normalize. So the check passes. Normalize returns the same thing. This if statement passes, and then we move on to the rest of the code. The rest of the code has this decode URI component. What does that do? That basically beautifies the string, right? It says, oh, you got %to e. We need to decode that from the URL, from the URL element, from the string itself, and then it goes and provides you, the actual URL that was passed to you, and that then gets passed to subsequent code of logic down there, which says, now I need to actually serve you the file. So I use my root directory, /public that was defined, append to it, concatenate to it that file that you, or URL to file that you are trying to get, and then we get the path except public / package join JSON to path join actually resolves to a file outside, right? Because that's essentially concatenating the two file paths. And then if you did that, you get the package JSON for the file. And this is why ST was vulnerable to it. I think it's interestingly enough to also learn about how the maintainer fixed the code, not just learn about the vulnerability and why it happened. And you can see what was happening here. Essentially, the path normalize part of the code was kind of, put aside for a second. First off, we did all the path decoding. What you see here is, the p-replace parts or regexes that essentially do what URI, the code URI component does, which I don't know why they chose to do that instead of the other thing. But essentially, the ordering matters. Right now, path normalize is at that last part because you want to evaluate the string after you've basically done all data modifications to it, whether that's decoding it, sanitizing it, filtering, doing all the path relative path check and all of those kind of things. And so getting it right is that nuance that even this top very, I think, top popular dependency for handling static files got wrong is those very subtle differences between how those APIs work and what do they actually do. So getting it right and having it in a specific order essentially would save you from having a path traversal attack. Now, this was fun and all, but also there are other cases of path traversal and where it finds us. For example, path traversal in VS Code extension. So Sneak went on and did this research on a lot of VS Code extension in terms of finding if there are malicious extensions there or even specifically just vulnerable extensions. And it found several vulnerable extensions that you might install on your package JSON. This is one of them. It's called Open in Default Browser. Essentially what it is, if you run VS Code like here, you view an HTML file and you just want to pop it up on the browser. So you right click it and then open a default browser. That's what it does. It's a pretty popular extension for what it does, which is getting almost 1 million downloads just for this. But it has a path traversal vulnerability, which I'll show you what happens. So in this video, what you're going to see is a browser on the right, which is the victim's browser and their IDE. And you're going to see also several terminal consoles that are going to mimic the attacker and how they set up the attack. And what they end up doing is they're going to send a specially crafted URL link to the victim, which is this. It just needs to open it, not do anything at all. Just click on the link, open it. The moment you did that, you will see I'm firing off a few of those terminals, and I'm basically serving files, which now you clicked on something was downloaded for you, and then you will see ls on the other screen. And you will see on the left there that suddenly the attacker, which has all of those terminals, has more files. Basically, they were able to get the keys, a secret file that existed on the victims. So imagine you working, at the conference, at work. It doesn't really matter where because it's not a network-specific thing. It's the fact that when you are using VS Code and this vulnerable extension, that vulnerable extension fires off a web server to serve the HTML file that gets rendered. But it does it, and it has some very specific, let me move on, very specific code issues that allow it to anyone else to actually circumvent everything related to the extension itself and specifically just get any file I want from your computer as long as I know the file path. This is what the extension did. I'll give you a second to admire it. If you call off what is going wrong here, let me know. Problem is here. We decode the URI component. That's fine. So RSA, my SSH key is decoded to its actual file path representation. Then we just join it. And what did we forget to do? There's generally no check if that file should be served or not. There's the whole check of, if this is, the rated code to the project opened on the VS Code workspace or not, doesn't exist. It just serves whatever you give it, unrelated. It's open, just get all the files you want, file extension kind of thing. So the problem with those kind of things happening on VS Code is we all use, IDEs. I'm pretty sure a bunch of us here use VS Code, but we're vulnerable to this. We're targeted as developers, which I'll get to in a second. But before that, there's no, CVEs or audits that say, hey, this extension is vulnerable. And so there's no alert mechanism that tell us to like maybe not use the extension. And we found several of those extensions that have vulnerabilities that allowed people or attackers to basically employ on you as developers and myself those kind of attacks. The only thing they need us to do is essentially click a link. The moment that we open it, doesn't matter where you are, firewalled or not, that's game over, and I can access files on your systems. Okay, so please take caution when you do that and understand that those kind of things really happen. Developers are actively targeted, both myself and you. Lastly, to kind of close this up, I wanted to take you further down this rabbit hole and show you how issues are not just secure coding and vulnerable dependencies and even VS Code extensions. Actually, things like the Node runtime, which is an amazing project, but still, has vulnerabilities and has secure coding issues. One of them was actually Path Traversal, and you could exploit known versions of Node.js if they're like still running somewhere with this and access files. Let's see why this happens. In the case of Node, because the code here is a bit long and not very easy to follow, I'll just go ahead and skip the whole code reading exercise. I've already done it for like a few of those code examples, and get into like what is actually happening and should be happening. So if you look at that path variable that I gave you, /foo, /, you would expect that if I normalize it, right, we evaluate the string, we basically want to have /etc/passwords, right? But actually, we actually get a very different behavior from what we expected to have. Now, this issue inside Node actually iterated through not just normalize, but also other file path APIs. If you had used them, like path resolve and path join, would actually suffer from the same secure coding issue, and didn't happen there. And so if I have this Node runtime, which is, I have, Express is not vulnerable, ST is not vulnerable, everything just works and my code is amazing. Yet still, if I would do a curl request here to this Node running application, I'd actually be able to get really into every file that is running on the server itself. Now, this is known as a critical vulnerability for, since 2017 for Node 850, which is pretty old, and I hope no one is using here. And that is also why I felt comfortable to talk to you about this and not expose users running now in production in recent versions of Node, because those also have vulnerabilities. So please stay on the latest. And I wanted to show you a sec of like how people weaponize this really, really fast. So on my left here, I've got the Node app running, and you see I've ran it a couple of times because I changed IPs here through the conference in the hotel room. And now we're off with this, 195 IP address. And this is really just the same code that I showed you here, okay? This is the exact same thing. It's a bit different, but everything there stays. There's this other project called .pun, which exists for like a decade long, okay? This is like exists for like a long time already. What it does is essentially executes, it weaponizes path traversals. You give it a URL, you give it a bunch of command line arguments that help it understand what you're trying to do and how it should attack a web server, and then it goes off and fires a ton of requests. So I could take that, and I will show you in a second how I run it. And there we go. And so you could see I basically just gave it my address. I told it, look for files in /etc hosts, run every, I think this is like 5 milliseconds. This is the URL that you're trying to do. So traversal is apply all of your string permutations under traversal, and then search if the file that you get has localhost in it. Why am I doing that? Because I actually want to I want to lower the amount of false positives, because some firewalls are like kind of like anti-hacking thing will just give you some data back, but it will be a false positive. So I did that, and it says, I'm now ready to run. And the moment I press return, it's going to execute a ton of URLs with different permutations of things that I don't know about and you don't know about, like how to construct file paths in different ways that some systems, different operating systems might be vulnerable to. Now, it takes a minute, and I don't want to take the whole 1 minute of time here, but I'll show you what was happening just before. essentially here, when it was done, and this is the test I ran before, I had like a different IP address. It already found this to be vulnerable, and it took it about a minute to complete, and it found this exact thing. The only thing I needed to do is literally copy paste that thing, and that's it. I have access to it. So we can do that, and the server is still running, so I can go ahead and maybe change just the IP address here that I have running now. Oh, did I just get that one? There we go. That's the etc hosts file of this container on the left running on my host. So my request was just fine. So what can you do about those kind of things? So first off, we talked about like how common path traversal is in like code, dependencies, VS Code extensions, even the runtime itself. So it's something I hope like about now and understand to take more into consideration when you work with file path system APIs. And like I said before, I think the fact that you have a path traversal vulnerability, it may sound not as harsh, like, okay, someone can access my CSS or JavaScript assets, but it's really, really, really more than that. So please understand that. I would hope to give you, leave you off with some takeaways. So at Sneak, we've got this whole like free tooling for developers where they could just scan their code and find vulnerabilities and fix them. And what I did was I wanted to like take that we have like this VS Code extension that as you code, it will like give you like linter issues of vulnerability that it finds. And I did that experiment with ST. So I loaded ST, which is on the right here, you could see the actual function. And I copied it to my example project on the left. You could see it actually found this inputs and unsanitized input that results in path traversal and directory traversal vulnerabilities. So, use that. There's like a lot of resources. If you go to like Sneak Learn or something else, just, learn about path traversal vulnerabilities to scale up and hopefully do not have any secure coding issues in the future. Thank you for your time. Any questions, I guess? Okay.
If there's questions, you can just take them now.
Yeah. And if I don't know them, I'll just ask ChatGPT. So we'll see.
Or I have more ChatGPT jokes, so there's that too. So.
Yeah.
Like, why did the TypeScript developer go on a diet?